basicsxxi. Hopefully this one goes better than the last for some of y'all. Let me find my little magic pen and I'll get started. Although I can probably do the first one via typing. Alright, so I'm going to go through here, and I got log is bay for you to get this down. But if log is bay, there's the base, she's 4. Notice it's followed immediately by a. A is 2x plus 5. And then e is 2. So now I'm ready to convert to an exponential. And in the exponential, the base shall be 4. She shall be raised to the second power, and she shall equal 2x plus 5. Now I know 4 squared is 16. You should too. And the next thing I'm going to do is subtract the 5. If you're curious what happened there, I subtracted 5. And the next thing I'm going to do is divide by 2, because the opposite of multiplication is division. So there you go, 11 halves. All right, number 2, express using the notation x to the power over root. I know you might look at this and think the power is 2, but I wish I had a set of parentheses here. Every bit of this is inside that radical. Every bit of it. And it's understood to be raised to the first. So we talk about the power here. The power is 1, and the root is 3. There's only one way you can actually express that and be correct. The only correct way to express that is all of 2x squared minus 5 to the 1/3 power. And the reason we do this, by the way, is so we can push buttons at a calculator. That's why we do it. Alright, solve the factored polynomial. It's multiple select, show the initial setup. So, by the ZPP, which is zero product property, I know 3 things: that x minus 2 must be 0. We're going to take each factor and set it equal to 0. Or 2x minus 5 must equal 0. Or 3x to the second minus 27 must equal 0. So by adding 2 to both sides, I get that x is 2. By adding 5 and then by dividing by 2, I get x is 5 halves. And this one, probably 70% of you missed on benchmark. Notice it's an x squared. It has 2 answers. You see that 2? That 2, I don't know how many times I've told you this, but exponent of 2. 2 answers. So let me recopy that down. And if you're thinking the next step is to add 27, you are 100% right. And if you're thinking the next step is to divide by 3, you are also 100% right. And the next step would be to take the square root of both sides. And I have to write this out. So we take the square root of both sides. We introduce the plus or minus symbol. The square root of x squared is x, and the square root of 9 is plus or minus 3. Like I said, 70% of you missed this because you forgot the plus or minus symbol. 4, if f of c is 0, what do we know? And it is multiple select. Now let's talk about f of c. F of c is 0. This literally means x equals c. And if we shift left, we get x minus c is 0. X minus c is a factor. Enters evenly as another nice way of saying remainder of 0. Not true. X equals c is a 0. Notice it literally says c is a 0. F of c is a 0. And the remainder when dividing by x minus c is 0. So there's 4 things you have to pick out there. And they all come from knowing a little bit of function notation. Solve this one. By hand answers written in terms of E get full credit. Y1, Y2 answers expressed as a decimal get half. So I'm going to divide the 3 out first. That'll give me the ln, which by the way is base E, of 4x minus 3 equals 3. Now I'm going to do log is bay. My base is E. My exponent is 3. And G equals 4x minus 3. I'm going to add 3 to both sides. E cubed plus 3 is 4x. And then I'm going to divide by 4. Now if that's too much for you, and even if it's not, like, everybody should be checking their answers here. This is a really, really simple thing to do in a calculator. I don't know how many kids didn't bother to do it in a calculator last time, but it was, if it's 1, it's 1 too many. Zoom 6. Second trace 5. Press that cursor a couple times. Enter, enter, enter. And I got 5.7714. Alright, let's check my answer. My answer was, I think E cubed plus 3, all divided by 4. So we match 5.7714. Determine the average rate of change from x equals 3, I'm going to highlight that, to x equals 8 using the table. Now your formula is f of b minus f of a, sitting pretty over b minus a. So they're telling us that this is b and this is a. And let me just do this one at a time. When b is 8, f of b is 12. Notice that it says f of 8 equals 12 for those of you who can't read tables. So I'm going to put a 12 right here where that f of b is. And the other one is when x is 3, that goes there. Oh, by the way, you know, it might help some kids to put the numbers in first, because 8 and 12, then 3 and 0. And I get 12, because 12 minus 0 is 12, over 5, because 8 minus 3 is 5. 12 fifths. Not a hard skill. Solve this thing using the quadratic formula. And if you need to be singing it, so be it. Quadratic formula goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. And then plug some crap in. So opposite of a negative 8 is a positive 8, plus or minus square root. And I'll show it in parentheses wrapped. Maybe a couple of y'all make fewer mistakes. Negative 8 all squared minus 4 times a, which is 2, times c, which is 5. Bad looking 2 there. Can't even fix it. All over twice a 2. Now, what's inside? It's a shame I have to show that you have, some of you just have to push buttons. Root 24 is inside. Okay. 8 plus or minus root 24. Both pieces are sitting over a 4. Not one, like some of y'all will do 8 over 4 and then you forget that the other piece is also over 4. 8 over 4 is 2. Now root 24 could be thought of as root 4 times root 6. It is not something like 3 root 8. It is not something like 8 root 3 or 2 root 12 or 12 root 2. None of those work. Like some of y'all write crap down and it doesn't make any sense. This is root 24 as a decimal. Some of y'all will write 3 root 8. They're not the same. None of these are correct. this is how she simplifies. And root 4 is 2, so 2 root 6. So we have 2 root 6 also over a 4. The 2's cancel on that part. 2 over 4 is a half. Root 6 over 2. Final answer. No other way to do it. Doesn't matter what you think. That is how it is. Which of the following is equivalent to the 4th root of 256? In a perfect world, this is a non-calculator problem. It is. You're not supposed to, but you have one. Your correct answer choices are this one, this one, this one, that one. Why? Well, because this is literally how you push buttons. Two, 5, 6 to the 1/4 is 4. So there's those two. Everybody should know what the square root of 16 is. And if I look at this one, I think 64 to the 1/3, which I don't know how many times I've done it with y'all in class, but the cubic root of 64 has always been 4. I mean, they're all 4, so there you go. All right, this guy. We always change the sign. This one doesn't need a placeholder. You just have to make sure you get your signs right. And we drop. And we multiply. And we add. And we multiply. 4 and 9 makes 13. Sorry, and we add, we don't multiply. And we multiply. And we add. That is my remainder, which is preceded by a constant, which is preceded by an x, which is preceded by x squared. And I'm going to double check myself, because it's early in the morning for me, because daylight savings time. I don't see anything wrong. So this is my x squared, 2x squared, plus 3x, plus 13, plus 44 pieces of x minus 3. Alright, so your rule is right here. She says a sub n is the first term plus parentheses n minus 1 times the difference. Looks to me like the difference is minus 9. And the first term is negative 6. Notice it's a multiplication operation. Some of y'all don't put parentheses, so you actually take away 9. Some of y'all's is just your syntax. You have crappy syntax. Negative 9 times n is negative 9n. Negative 9 times negative 1 is positive 9. And when we put things together, we'll have negative 9n, and negative 6 and 9 makes 3. That looks really horrible, doesn't it? Negative 9n plus 3. There we go. That just looks bad. An arithmetic sequence is given as 5, 12, 19. Find the sum of the 3rd through 10th terms. You may use formulas or write it out. So the sum of n things is given to you. It's n over 2, first plus last. In this case, it's going to be 3rd plus 10th. And I'm going to do this 2 ways. Obviously, I got to do the math. If I want the 10th term, I'm going to plug into this thing. If I want the 10th term, I've got to be the first term of 5. And wherever I see an n, I'm at 10. And the difference appears to be 7. And again, I'm just plugging into a formula. 5, 10 minus 1 is 9. 9 times 7 is 63. A sub 10 is 68. And the 3rd term is 19. And n would be 10 minus 3, add 1 back, which is what? 8. So it's the sum of 8 things, and she is 8 over 2. Third term is 19. 10th term is 68. And I'm going to push some buttons here. 8 over 2 is 4. We have 19 plus 68. 348. Now, if you don't want to do that, we'll just write it out. Starting on the third term. So we got 19, and what are we adding here? 7, 26. We add 7 more. We're at 33. We add 7 more. We're at 40, 47, 54, 61, 68. And then I just, push buttons. The reason you have to write it out is because kids who write it out have more luck than kids who don't. And there you go. Add all that stuff together and you'll get 348. The geometric sequence is given as -3, 2, -4 thirds, right? Both a recursive, and they tell you it's geometric. So your ratio is always going to be the second over the first, which is 2 over -3, which is -2 thirds. The rule for recursive is quite simple. It says the nth term is the ratio times a sub n minus 1. And, of course, you must define a sub 1. So let's just do that. We're going to put that right there. The nth term is -2 thirds of a sub n minus 1. And the first term is -3. The rule for explicit is also given. It says a sub n is the first term times the ratio raised to the n minus 1. And the first term is, again, -3. The ratio is found to be -2 thirds. And the exponent is always n minus 1. Moving forward. This is a y1, y2 problem. Plus 2 if you can do it by hand algebraically. Geometric sequence has a first term of 5, a common ratio of third. The sum of n terms is that funky looking number. How many terms were there? So let's do the setup here, and the formula is given to you. It's over there on the right. The sum of n things, and I'm just going to plug into it in just a minute, is the first term times 1 minus the ratio to the nth power over 1 minus the ratio. I don't have a clue how many things there are. So the sum of x things is the first term, which is 5. Sorry. I don't have a clue how many there are, but I do know the sum. It says the sum is. So 3, 5, 8, 7, 2, 2, 6, 5. I don't think this fraction simplifies anymore. I played with it for a minute. If it does, so be it. Equals the first term, which is 5. Ratio of a third. So 5 parentheses, 1 minus, I'm going to put that third in its own set of parentheses, raised to some unknown value, we'll call it x, sitting over 1 minus 1 third. There's y1, there's y2. See, I'm going to math, num, n over d. Sadly, I'm just sitting here thinking of all the kids who will miss this. I wish I could get you to try. The ratio was a third. And if I don't know what 1 minus a third is, the TI-84 can do it. And then I zoom 6. I'm going to have to play with the window. Or maybe not. No, I'm not, because the sum is pretty small. We should start seeing an exponential function being graphed. We may or may not. There she is. Now, if you're tempted to do, you're not going to see the answer. If you do second trace 5, you're not going to see an answer. Get close, press enter 3 times. It's going to say something funky. No sign change. What that means is your window wasn't big enough. I'm going to adjust my X max up to 20. The thing only grows, well, it grows slowly. In some sense, it flatlines out. It might be a good equation for logistical growth. Second trace 5. Enter, enter, enter. So I did have adjusted. See that 14.9999999? That's a rounding error by a calculator. It goes on forever. This is 15. That is a rounding error. But it's 15. Alright, so by hand, I will knock off points if you put 14.9999999 because you have no common sense. It says how many terms. It's going to be a whole number. Alright, by hand. Oh, this could be kind of ugly, wouldn't it? Alright, so what can we do? I'm hoping that the calculator will not have an issue with this. We are going to have to figure out what this is. 1 minus a third is 2 thirds. And there's still a 5 out front. Now 5 divided by 2 thirds is the same thing as 5 times 3 halves, which is 15 halves. It equals this ugly number. And what we're going to do is we're going to divide by 15 halves, which is the same as multiply by 2 over 15. So let's take my hideous looking fraction and I bet the calculator is going to convert it to a decimal. 358.72265, sitting pretty over 478.2969, and we're going to multiply it by 2/15. Yeah, I thought the calculator would do that. It would round the decimal. So how many 9s have I got? 7 followed by 303. Yeah, 7 followed by 303. Calculator's already had to round 0.999999903 equals 1 minus 1/3 to the x. We're going to take away 1. And we got something really small. That's negative 6.96 times 10 to the what? Negative 8. That equals negative 1/3 of x. I'm going to divide out the negativity. Now it's positive. I'm going to do log as bay. My base is a third. It is raised to that funky looking decimal. And it equals x. Sorry, I did that entirely wrong. Brain fart. my base is a third. I said it, but I didn't write it. The argument inside is that really funky looking decimal. And it equals x. So I'm going to go ahead and do change of base here real quick. I'm going to have the natural log of that funky looking decimal divided by the natural log of a third, because 1/3 was the base. And there we go. We still have a rounding error. It says x is 14.99999 ... 15. Anyways, you pick your poison. You can y1, y2, or you can go for the extra credit. I don't care. Almost done. Completely simplify this expression such that all exponents are positive. If you don't know what 15 over 50 is, by all means, push buttons. 3/10. Math. Enter, enter. So there's a 3 up top, a 10 down low. We'll focus on the pieces here. I can move that 7 up high, change its sign to positivity. I add exponents, 7 plus 4 makes 11, and it's up top. And I'm looking at this one. This is x to the 23rd over x to the 14th. It wasn't supposed to be 23. Typo. Division is subtraction. This becomes x to the 23 minus 14, and 23 minus 14 is x to the 9th. Also up top. Alright, moving forward. Completely simplify the cubic root of 128x to the 16th. So let's look at this piece by piece. Piece by piece. 128 happens to be 2 times 64. The cubic root of 64, again, is 64 to the 1/3 power, for those of you who hadn't paid a lick of attention. Hopefully you are now. This becomes 4 cubic roots of 2. Now the idea here is we do power over root, remainder inside. 3 enters 16 5 times, remainder of 1. Power over root. 3 enters 13 4 times, remainder of 1. 4 times, because 3 times 4 is 12. Y left inside. So we have a 4, an x to the 5th, and a y to the 4th all outside. And what's stuck inside that radical is a 2, an x, and a y. Last one. Finally. Solve log base 6. 3x minus 6 minus 3 equals log base 2, blah, 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 plus 1. I'm an ln guy, so I'm going to do ln 3x minus 6. Sitting pretty over ln 6. And then minus 3. And I have change of base written for you. Like, I don't understand the issue. But whatevs. I haven't understood the issue for a long time. My guess is your spatial reasoning skills are crappy. You just get confused when you look at lots of things. It is how you were made. Anyways, I just typed everything in using change of base, and now I'm going to go to y equals. What do we have here? We have the ln of 3x minus 6. Sitting pretty over the ln of 6, because what's high stays high, what's low is low. And then minus a 3. And then we have the ln of 4x minus a 9. Sitting pretty over an ln of 2, and then it says add 1, because I didn't change much from the last one. And then I zoom 6. And it won't look like the graphs intersect, because calculators don't draw logarithms right. Make sure I didn't have a typo in there. Okay, second trace 5. You're going to have to press that right button a while to see your cursor. Once you see it, press enter. I'm going to press it again, make sure it's there. Enter, enter. There's only one answer because the blue line shall never catch the red line. 2.2643. 2.2643. 643. Always 4 decimal places. And that, boys and girls, is Basics XI.